Welcome to The Explainer. If you've ever thought about learning to code or even just wondered how it all works, you are in exactly the right place. Today, we're going to demystify the whole thing by breaking down the absolute basics of Python. We're starting from square one.
Okay, so here's our game plan. We're going to start with the big picture, like how do you even talk to a computer? Then we'll meet our language, Python, look inside the programmer's toolbox, see how those tools work, and finally, put it all together to build your very first program. Let's do it.
So, first things first, we have to tackle the biggest hurdle right out of the gate. The simple fact that we don't speak the same language as computers. Not even close.
It's a really good question, right? Because we think in ideas, in feelings, in concepts. Computers, well, they think in something much, much more literal.
And this really gets to the heart of it. Our language is messy, it's full of context and hidden meanings. A computer's language, on the other hand, is perfectly literal and precise. Deep down, it's all just a massive series of ones and zeros. There's no room for kinda or sort of.
So, this is where programming languages come in. They are the essential bridge. They're a special, structured language that we can learn to write, which can then be translated perfectly into the ones and zeros a computer needs to get the job done.
With that idea of a translator in mind, let's meet the one we're going to be using for our journey. It's one of the most famous and widely used programming languages in the entire world, Python.
So why Python? Why does everyone love it so much? Well, for one, it's famous for being readable. The structure is simple, it almost looks like plain English sometimes. It's also totally free, it runs on pretty much any computer you can imagine. And, this is important, it's interpreted, which makes learning it really interactive and fun.
Now that interpreted thing is a really big deal. Think of it this way, an interpreter is like a live translator. You say a line, they translate it. It happens instantly. That's Python. It runs your code line by line, so you see what's happening right away. The other style, a compiler, is more like a book translator. They have to translate the entire book before you can read a single page. Python's immediate feedback is just fantastic for learning.
Okay, so we've chosen our language, now it's time to pop open the toolbox and see what we've actually got to work with. What are the essential tools we'll be using?
The first and most fundamental tool you have is the variable. The absolute best way to think about it is just a labeled box. That's it. You give a box a name, and you can put stuff inside it to use later.
Right. So, if variables are our boxes, what do we actually put inside them? Just like a builder needs wood and steel and glass, a programmer needs different kinds of data to build with. And here are the most common building blocks in Python. You've got your basic numbers, for both whole numbers and decimals. You've got text, which we call strings. And then you've got these really useful containers, like lists for keeping things in order, and dictionaries for storing connections between things, like a word and its definition.
So, we have our boxes, and we have our building materials to put in them. That's great. But you can't build a house just by looking at a pile of bricks, right? You need power tools to actually do something with them.
And in the world of programming, those power tools are called operators. These are the little symbols that do all the actual work, the adding, the comparing, the moving things around.
Here are the big ones you'll use all the time. You've got arithmetic operators for doing math, you've got assignment operators, which is how you put stuff into your variables, relational operators for comparing two things, and logical operators for combining ideas and making decisions. Okay, let's see this in action. It's way simpler than it sounds. First, we'll make two of those labeled boxes, two variables. We'll call one length and put the number 10 in it. Then we'll make another called breadth and put 20 in that one.
Now, we bring in a power tool. We use the multiplication operator, that little asterisk, to tell the computer, hey, take whatever's in the length box and multiply it by whatever's in the breadth box. Then we use the assignment operator, the equal sign, to store that result in a totally new box called area.
And boom, there's our result. The computer does the quick math, and the area variable is now holding the value 200. See? Simple as that.
All right, so we've seen all the individual parts. The variables, the data, the operators. Let's put it all together now and look at the flow of an actual working program.
You know, it's funny. Almost every single program ever written follows the same basic pattern. Step 1, get some information. We call that input. Step 2, do something with that information. That's the process. And step 3, show the result. And that's the output. Input, process, output. That's the fundamental rhythm of programming.
So how do you handle that input and output? Well, you can think of Python's input and print functions as the doors and windows to your program. Input opens the door to let information in from the user, and print opens a window to show the user what you've done. It's how your program communicates with the outside world.
Now, one last thing that's super important to know. When you're building something, anything, it's never perfect on the first try. In programming, the process of finding and fixing those little mistakes is called debugging. It is not a sign that you failed, it's just a normal, natural part of the building process.
And this all leads to a much bigger idea, which I think this quote captures perfectly. Programming isn't just about ones and zeros and cold logic. It's a creative act. It's an art form. It's about using what you know to build things that are useful, helpful, and sometimes even beautiful.
So there you have it, your first real look at Python. We've seen the blueprint for how to talk to a computer, we've opened the toolbox, and we've put the basic pieces together. With just these simple building blocks, you already have what you need to start creating. The only question left is, what will you build first?